So hello everybody, today we're going to be doing a somewhat homogeneous differential equation. It's not exactly homogeneous, but I'll show you how we can make it into a homogeneous differential equation. So 8x plus 25y minus 62 times dx minus 11x plus 4y minus 11 dy is equal to 0. So instead of rewriting all of this, I'll just erase this and I'll put in an equal sign here. From here it follows that dy over dx is equal to 8x plus 25y minus 62 over 11x plus 4y minus 11. Okay, now we're going to make a change of variables. We're going to say that, we're going to say that x is equal to some other variable u plus some unknown constant alpha. And we'll also say that y is equal to v plus some other unknown constant beta. Okay, and of course v is a function of u. Keep that in mind. What does that mean? Well, that means that when we differentiate both sides of this here part with respect to u, we'll get that not like this. When we just do it a little bit more, okay, so from here it follows that dy is equal to dv, and from here it follows that dx is equal to du. So when we differentiate both sides, and from these two equations it follows that dy over dx is equal to dv over du, which is, that's basically the same, which is the same as v prime. Okay, now let's plug in a couple of things. This, and this right here into our equation, into our starting, into our previous form of the equation. So we'll get that v prime is equal to 8 times x, but instead of x we'll put in u plus alpha, plus 25 times y, but instead of y we'll put in v plus beta, and minus 62, everything over 11 times u plus alpha, plus 4 times v plus beta, minus 11. Okay, now let's spread this out a bit. From here it follows that v prime is equal to 8u plus 25v plus 8 alpha plus 25 beta minus 62, everything over 11u plus 4v plus 11 alpha plus 4 beta minus 11. Now we're going to be solving a nice little system of equations, namely both of these here parts, which don't contain any variables but strictly constants. We're going to set both of these parts equal to 0. Okay, so let's go ahead and solve this system. So 8 alpha plus 25 beta is equal to 62, and 11 alpha plus 4 beta is equal to 11. Okay, so from here it follows that alpha is equal to 62 minus 25 beta over 8. And let's just go ahead and plug that into our second equation. So 11 times 62 minus 25 beta over 8 plus 4 beta is equal to 11. Let's now multiply both sides by 8, and what we're going to get is 11 times 62, so 11 times 62, which is equal to 682, minus 11 times 25 minus 275 beta plus 32 beta is equal to 88. Okay, so negative 275 plus 32 is equal to negative 243 beta is equal to 88 minus 682, which is equal to negative 594. So from here it follows that beta is equal to 594 over 243. Now let's just go ahead and try to simplify this fraction a little bit. So 594 is divisible by 9, so that's the same as 66, and 243 is also divisible by 9, so that's equal to 27. Now let's go ahead and simplify this a little bit further. So both of them are still divisible by 3, so we'll get 22 over 9. Okay, so in other words, beta is equal to 22 over 9. Okay, so beta is equal to 22 over 9. Great. Now let's go ahead and find alpha. So we know that alpha is then equal to 62 minus 25 times 22 over 9, and everything divided by 8. So alpha is equal to 9 times 62, so that's like everything over 9, 558 minus 25 times 22 minus 550, and everything over 8, so 62 times 9, 558 minus 25 times 22. Okay, so this is basically the same as 8, so this and this can cancel out, so alpha is equal to 1 over 9. Okay, so beta is equal to 22 over 9, and alpha is equal to 1 over 9. So that means that our original switch, our original substitution, is with the constants known and this time x is equal to u plus 1 over 9, and y is equal to v plus 22 over 9. Okay, great. Now, when we put in this substitution into this part right here, we'll get that v prime is equal to 8u plus 25v, 8u plus 25v over 11u plus 4v, over 11u plus 4v. Now, let's just go ahead and divide both the bottom and the top by u, and we'll get that, and that's the same as writing 8 plus 25 times v over u over 11 plus 4 times v over u. Now, let's put in another substitution. Let's say that v over u is equal to some function of u, let's call it z, and from here it follows that v is equal to u times z, and when we differentiate both sides with respect to u, we'll get that v prime is equal to, we're going to go ahead and use the product rule, u prime z, which is just z, and z plus z prime times u. Okay, so we'll get that z plus z prime times u is equal to 8 plus 25z over 11 plus 4z. Okay, so let's go ahead and subtract z from both sides. So we'll get that z prime u is equal to 8 plus 25z minus 11z minus 4z squared, everything over 11 plus 4z. So z prime u is equal to 8 plus 14z minus 4z squared over 11 plus 4z, and z prime u is the same as writing dz over du times u. So in other words, we can rewrite this problem as du over u is equal to 11 plus 4z over 8 plus 14z minus 4z squared dz. And now we're supposed to integrate both sides. So how do we go about integrating? The left-hand side is easy, but how do we go about integrating the right-hand side? So I'm just going to do that right here. So the integral of, okay, before doing this, I'm just going to go ahead and solve the equation minus 4z squared. We're going to be doing partial fractions. Plus 14z plus 8 is equal to 0. So minus 4z squared plus 14z plus 8 is equal to 0. So I'm just going to multiply everything by negative 1 so that I get, okay, instead of negative 1, I'll just go ahead and multiply everything by negative 1 over 2, and I'll get that 2z squared minus 7z minus 4 is equal to 0. And from here, I'll get that z12 is equal to 7 plus or minus the square root of 49 plus minus 4 times minus 4 is 16 times 2, and everything over 4. Okay, so 49 plus 32 is equal to 81, so that's going to be 7 plus or minus the square root of 81 is 9 over 4. So z1 is equal to 7 minus 9 is negative 2 over 4 is negative 1/2, and z2 is 7 plus 9, which is 16 over 4, which is just 4. Okay, so that means that we can rewrite minus 4z squared plus 14z plus 8 as negative 4 times z plus 1 over 2 times z minus 4. Or, in other words, this when we distribute this a little bit, we can rewrite this as 4z plus 2 times 4 minus z. So in other words, we can rewrite this integral as the integral of 11, whoops, not just yet, so we still have to do the partial fractions. So when we do this, 11 plus 4z, we have to rewrite this as partial fractions. So 11 plus 4z over 4z plus 2 times 4 minus z is equal to a over 4z plus 2 plus b over 4 minus z. And we're just going to use the cover-up method. So when we put in here, z here has to be equal to negative 1 over 2 in order for it to be 0. So I'm just going to cover this up. So we'll get that a is equal 11 plus 4 we'll get that a is equal to 11 plus 4 times negative 1, 2, 4 times negative 1 over 2 minus 2 over 4 plus 1 over 2, which is the same as 4.5, which is the same as 9 over 2. So, and of course, this here is 1. So 11 minus 2 is 9, and this 9 cancel. So A is equal to 2. And as for B, I'm just going to go ahead and say that that in this case, B has to be equal to 4 in order for it to be 0. So B is equal to 11 plus 4 times 4, which is 16, over 4 times 4, which is 16, plus 2, which is 18. Okay, and this is 27 over 18. When we divide it by 9, we'll get 3. When we divide it, so which is the same as 3 over 2. So in other words, our original integral, I'll just go ahead and call it I, is equal to 2 times the integral of, okay, we don't have an A anymore. I mean, we do have it, but we know it, of dz over 4z plus 2 minus 3 over 2 times dz over z minus 4. Okay, and now we can rewrite the first part of this integral as 1/2 times 2 over 2z plus 1 dz minus 3 over 2 times the integral of dz over z minus 4. So, and this is by using the ln rule. Ln of the square root of 2z plus 1 minus the ln of the square root of z minus 4 to the third power. Or in other words, this integral is equal to the ln of 2z plus 1 over z minus 4 to the third power. Okay, and when we look at this part, everything again, so we'll see that ln of u is equal to ln of the square root of 2z plus 1 over z minus 4 to the third power. And we'll put in plus ln c. So by using the properties of logarithms, we can just conclude that u is equal to some constant c times all of this. But now let's remember that we want to have everything in terms of x and y. So instead of u, I'm going to be rewriting u. So instead of u, I'm going to rewrite x minus 1 over 9. So x minus 1 over 9 is equal to c times the square root of 2 times what was z v over u, 2 times v over u plus 1 over v over u minus 4 to the third power. Okay, so x minus 1 over 9 is equal to c times the square root of 2 times v is equal to y minus 22 over 9, y minus 22 over 9 over x minus 1 over 9 plus 1 over y minus 22 over 9 over x minus 1 over 9 and minus 4, everything to the third power. Now we can go ahead and square both sides, and then we'll get that x squared minus 2x over 9 plus 1 over 81 is equal to c squared times whatever we're left with here. So 2 times 9y 18y. Yeah, I'm just going to rewrite it like this, and although it isn't a pretty solution, it can be made to look more pretty. All you need to do is a little bit of algebraic manipulation, and you'll get it. You can let me know about exactly what you get in the comments down below. As far as the differential equation part goes, this is solved. I hope you enjoyed the video. It was a long one, and I hope to see you again in the next one soon. Goodbye.